The sun burns at 27 million degrees at its core. 2 trillion galaxies blaze across the observable universe. The night sky contains more fires than grains of sand on every beach on Earth combined. And yet just 300 miles above your headspace sits at 455 Fahrenheit, almost absolute zero. The most powerful furnace in the solar system, burning with incomprehensible fury. And the space directly surrounding it is essentially frozen solid. That is not a paradox, that is physics. And once you understand it, you will never look at the night sky the same way again. Before we answer the question, we need to destroy something you have believed your entire life. You think you know what temperature is. But here is what nobody tells you. Temperature is not a property of space. Temperature is a property of matter. It measures one thing only: how fast particles are moving, how furiously they are vibrating. A hot object has particles jiggling at insane speeds. A cold object, particles barely moving at all. The absolute lowest possible temperature, called absolute zero, is the point at which particle motion drops to its theoretical minimum. That is 459 Fahrenheit, and nothing in the entire history of the universe has ever reached it. Here is the key that unlocks everything. If there are no particles, there is no ever reached it. Here is the key that unlocks everything. If there are measure the temperature. You cannot measure the temperature of nothing. Deep space is not quite nothing, but it comes terrifyingly close. In the voids between stars and galaxies, there is roughly one single atom per cubic meter of space on Earth. That same cubic meter of air contains 25 quintillion molecules. A 25 odd followed by 18 zeros, one atom versus 0.00000000000000000. That emptiness, that almost unimaginable void, is the foundation from the first distractions. Heat travels into space and into space.
Understanding directly 3 ways. Understanding should be
Cautiously directly from the pan into your hand. Particles pass energy to neighboring particles. Conduction and directly to neighboring particles.
Space directly to space objects are not touching. There is nothing to conduct through conjunction, nothing. The second is convection. Why trade from why defeat create currents that create a convection. Direction requires convection, eliminating your water. Gas space is a vacuum. Direction eliminated. That leaves only radiation. Heat travels to electromagnetic waves of right trajectories. No particles that cross 93 million miles of empty space to reach Earth. Also, no particles fractions for the perfect speed of light. It actually direction sun pours radiation that's not the direct direct the pulse waves up through space direct but space itself doesn't have direct waves so plus weight plus spacecraft without heating it because there is almost nothing there to be heated out. Only when irradiation hits the space does not touch does energy transfer and create a WAMP. So space is cold because the sun is too far away. So space is cold. Why the spacecraft enjoy the effect? The space travel system conveys the price of flow space but it's taken all it's there because it goes hand pools in space trust it's that for space cycle it's able for plus it affects why can take sex.
Why do astronauts' spacesuits manage heat, not just cold? Because space does not give you one extreme, it gives you both extremes simultaneously with nothing in the transition between them. On the sunlit side of any object in space, temperature can reach 250 Fahrenheit hotter than boiling water. On the shaded side, just a few feet away, it drops 250 Fahrenheit, same object, same moment. Inferno on one side, deep freeze on the other. The moon is the most vivid example. Standing on the lunar surface in direct sunlight, temperature reaches 250 Fahrenheit. Walk into the shadow of a crater, it plunges 290 Fahrenheit, 2 conditions. A few feet apart, separated by nothing but a shadow. Earth does not work this way because our atmosphere acts as a blanket. It absorbs heat, distributes it, and moderates extremes. Without that atmosphere, Earth would experience the same savage swings as the moon. The International Space Station lives this reality every day. Orbiting Earth every 90 minutes, its exterior swings between 250 and 250 Fahrenheit with every single pass. Every component engineered to survive that cycle thousands of times per year. Here is the most striking proof of everything we have been building. NASA's Parker Solar Probe is the closest any human-made object has ever come to the sun. In April 2021, it flew within 6.5 million miles of the solar surface, deep inside the sun's outer atmosphere. At that distance, its heat shield faces 2,500 Fahrenheit. Hot enough to melt steel, and yet just on the other side of that shield, the spacecraft's instruments operate at 238 Fahrenheit, same spacecraft. steel melting heat on one side, deep freeze on the other. This is not an engineering miracle. This is physics working exactly as expected. The shield blocks radiation from reaching the spacecraft. Because in space, radiation only heats what it directly strikes. Step into the shadow, and you go from an inferno to a deep freeze in inches. The vacuum itself has no temperature. Objects have temperatures, and their temperature depends entirely on one thing: their relationship with radiation. There is one final layer to this story, and it is the strangest part of all. The entire universe is filled with a faint, invisible glow of radiation left over from the Big Bang. This is called the cosmic microwave background. It was discovered entirely by accident in 1964 by two radio astronomers in New Jersey who noticed a persistent, unexplained noise in their antenna. It came equally from every direction in the sky. They checked everything, rechecked everything, even removed pigeons nesting on their equipment. The noise remained. They had stumbled onto the afterglow of the birth of the universe itself. That discovery earned them the Nobel Prize. That ancient radiation, stretched and cooled by 13.8 billion years of cosmic expansion, now fills every cubic centimeter of space at 455 Fahrenheit, just 4.7 degrees above absolute zero. This is the baseline temperature of space, the floor, and it is getting colder. As the universe expands, that background radiation continues to cool. The universe today is colder than at any previous point in its history, and it will be colder still tomorrow forever. The coldest confirmed natural place in the known universe is the Boomerang Nebula, 5,000 light-years from Earth, where gas expands so rapidly it has cooled to just 457 Fahrenheit, 2 degrees above absolute zero, colder than the void of deep space itself. One final detail that destroys a misconception most people carry their entire lives. Mercury is the closest planet to the Sun. It should be the hottest. During the day, its surface reaches 800 Fahrenheit, but at night, with no atmosphere to retain heat, it plunges to 290 Fahrenheit. Mercury, closest planet to the Sun, gets colder at night than Mars, which orbits more than 3 times farther away. No atmosphere.
No heat retention.
The warmth bleeds away into the vacuum, and the surface collapses. Now look at Venus, farther from the Sun than Mercury, and yet Venus is hotter than Mercury on average every single day, day and night, forever. Its thick atmosphere of carbon dioxide traps heat so effectively, the surface never cools. Average temperature 900 Fahrenheit.
Distance from the Sun is not the only factor. The medium that captures and holds radiation is equally important.
Here is the complete answer. Space is cold because there is almost nothing there to absorb heat.
The Sun's energy does not warm the vacuum. It travels through it invisibly, silently, and only creates warmth when it strikes something with mass. The universe is not evenly warm. It is a collection of isolated hot spots, stars, atmospheres, accretion disks surrounded by an almost infinite cold, and Earth is something extraordinary. Not just because it hosts life, but because it sits at exactly the right distance from exactly the right star, wrapped because it's at exactly the right atmosphere that allows heat to be absorbed, distributed, and retained. Allows heat to be absorbed, distributed, and retained. Without that atmosphere, we would be the moon.
Brutal heat in sunlight, catastrophic cold in shadow, silent, dead. The warmth you feel right now is not the default condition of the universe. It is a rare, precise, protected exception to a cosmos that is almost everywhere and almost always unimaginably cold, and that changes the question entirely. The right question is not why is space cold when the stars are so hot. The right question is how, in a universe that cold, did warmth like ours ever exist at all? If this changed the way you see the universe, there is one more layer waiting. We live inside a bubble carved by ancient supernova explosions, a vast invisible cavity in the galaxy that shapes everything around us. Most people have never heard of it. Subscribe and do not miss what we uncover next.